This is Geometry, Unit 4, Day 7. We're proving triangles congruent using two sides and the included angle, called side, angle, side. So if we start out with information, looking at RS, it's going to be congruent to UV in our diagram. Angle R is congruent to angle U. And segment RT is congruent to UW. So that shows that triangle RST has to be congruent. The second name has to be in the same corresponding order. So UVW. So now, instead of having all sides congruent to show two triangles congruent, we can do it with two sides and an angle, as long as that angle is in between those two sides. That's called an included angle if it's in between those two sides. So when we look at this diagram, what angle is considered included between these two sides? We have side GH and side HI. The angle being formed by that is angle H. And it's okay to name it with one letter because it's the only angle that's happening at that vertex. Look at another two sides, HI and IG. The angle that's being formed is right here in the diagram. HIG would be that angle. You could not name it with just one letter. You could not name it angle I. So which is the included angle if we're working with segment GI and segment IJ? The included angle is the angle that's being formed. It's the angle that's being made by those two. So that is angle GIJ. Those are included angles to the sides. We're going to look at our figure, and we've got to identify if there's enough information to show that the two triangles are congruent. And if they are, we'll write a congruent statement. So we're looking here at these two triangles. We notice they both have one tick mark. They both have another pair of sides with two tick marks, and they have angles that are considered to be their included angles. So decide whether enough information is given to prove the triangle's congruent. Answer's yes. By side, actually, it's side, angle, side. Notice how we have two S's labeled and the angle in between. The A is in between those two S's. The order does matter. And our congruent statement would be triangle TPQ. You can name that first triangle any way you wanted to. The second triangle has to be named in the corresponding fashion. So we said T to P, so it has to be S to R, and we have to end with Q. So now TPQ goes with SRQ. Our second diagram, we see that they both have a side with one tick mark. They both have a side with two tick marks. But we're missing that third bit of information. Does it have a reflexive property? Does it have vertical angles? Are there sides parallel? A lot of different things that might be happening. We do, if you notice, have two sides that are crossing, so it forms vertical angles. So at first sight, you wouldn't think we had angles at all, but we do have vertical angles congruent. So is there enough information? Yes. We're going to solve it by side angle side. Triangle NKJ is congruent to triangle. Now this order has to be in a specific fashion. We start with N to K, which is down the one ticker. So L to K. Letter C. It looks like we have one pair of sides the same. Of course, we have a pair of angles the same. And we have what's clearly the reflexive property the same. But notice that in this second triangle here, the angle that they give us is not included. It's not in between the two sides. But in this triangle, it is in between the two sides. They're not in the same fashion. In fact, they have to be SAS. It could not be in the other order, SSA. So we would say no. We don't have SAS congruence. We have information about SAS in this triangle, but we don't for the other triangle. On our second page, we're given 2 bits of information. We need to find the third bit of information that is going to help us prove the triangles by the way indicated. We've learned 2 ways so far. SAS, which we're doing today, and SSS, which we've done on a previous day. So I would suggest to draw out your 2 triangles, label them. They're saying, name one of them triangle ABC, and another triangle FED. We know that BC is congruent to ED. Segment AC, which is different than the other 2, is congruent to FD, so it gets a different number of tick marks. Now that's all the given information. We're supposed to prove the triangle is congruent by SAS. How would you show these 2 congruent by that? What else would you need to know? Notice we're given 2 sides, but not an angle. So the angle that's in between the 2 sides, called the included angle, is angle C in this shape, and it would need to be congruent to angle D in that shape. If we knew that, then the triangles could be congruent by side angle side. For our second figures, we'll name the first triangle ABC. We'll name the second one FED, and we'll do it in a random order this time. We'll do F, then E, and D. Segment AB is congruent to segment EF. Segment AC is supposed to be congruent to segment FD. Now, what's another bit of information we need to use to prove the triangle's congruent? We need a third bit of information. This time they're asking us to prove it congruent using just sides. So 3 sides of one triangle being congruent to 3 sides of another. So the sides I don't know that are matched up that would need to be, the third bit of information we would need is to say that segment BC is congruent to segment ED. The order should matter here. We went from the side that contained the 1 tick mark down to the 2 tick mark, so we need to start with the 1 tick mark down to a side that gets close to the 2 tick mark. our last figure, triangle ABC, and this time we'll name it in a different order. Notice that angle B is supposed to match with angle E. Angle, or segment in this case, AB is supposed to match with FE. Now what's the third bit of information we would need if we were going to prove them congruent by SAS, side angle side? We would need to know that BC was congruent to FD. That would be these two sides. For our fourth example, we're working on this proof. We've got this figure to the side. Look at our given information. Before you start on your proof, read through the given information and then decide how you could prove the triangle's congruent. If B is the midpoint of AE, then the two segments have to be congruent. If B is the midpoint of CD, then it's going to make two segments congruent. Now, just like we were practicing above, what would be another bit of information that we would need? If we were doing it by SSS, we would need to know the sides were congruent. But there's no reason those sides can be congruent. There's no midpoint. It's not a reflexive property. There's no reason those we can say are congruent. But the angle, here we have vertical angles, and we know if two angles are vertical, then they are congruent. So now we have side angle side. So we're going to say that B is the midpoint of AE. That was our given. What does that mean? If midpoint, then two congruent segments. We could then say that we have a midpoint. B is the midpoint of CD, which is also part of our given, and that makes DB congruent to CB. If we have a midpoint, then two congruent segments. When you're working through these proofs that have parts of it filled in, read over the information they give you. That'll help you start to set up the proof, help you identify what they're talking about. Angle ABD and angle EBC, look in your diagram to see where they're talking about. Those are your vertical angles. So if vertical angles, which we have, then congruent angles. If two angles are vertical, then they will be congruent. That's what we have there. So the two triangles are congruent by side angle side. We have two S's, and we have the A that is actually between those two S's. So side angle side congruence. Last one. Our given information shows that AB is parallel to CD. It's also congruent. What else would we need to know? Well, we have the reflexive property. That's when two triangles share the same side. That gives us two sides in both triangles the same. What do the parallel lines tell us? Parallel lines, in this case, are showing us this Z shape, which is giving us alternate interior angles. So we're going to start out with AB parallel to CD, which is your given, if vertical angles, no, not vertical angles here, sorry. What did we just say? If has to come before. So if two lines are parallel, then what's happening right now? Alternate interior angles are congruent. It's very important. You have to name the type of angles they are. Don't say if parallel lines, angles congruent. You have to say what type of angles they are, because all angles aren't congruent. Okay, we also know that AB is congruent to CD, and we also have the reflexive property of congruence. That gives us two sides and the angle that's in between. It's helpful when it's written in the perfect order, but notice that here we'd actually talk about it as SAS. So triangle ABC is congruent to triangle DCB by side, angle, side, congruence.